Today, a fan challenged me with Mystery Box, asking me to turn whatever's inside into a DIY antenna. This item looks strangely familiar. There's no way to get it wrong. I recognize it instantly. It's a CD, and honestly, this challenge already feels pretty easy. Looks like I was mistaken. When I picked it up, it felt like there wasn't just one CD inside. There were actually two. And the very first step I'm going to take is securing the two CD discs together. I'll align the sides that already have paper labels facing each other, then carefully glue them in place using liquid glue. This will create a solid, double-layered base, making the structure sturdier and easier to work with in the next steps. It looks firmly glued now, so the next step is drilling two holes into the surface of the CD. In my hand are two sets of bolts and nuts that fit perfectly into the holes I just drilled. Very convenient if I want to use them as connection points for wiring later on. For the antenna base, I'm using a small square piece of wood. It's simple, solid, and sturdy enough to hold everything in place. The hole I just drilled in the wooden base is a perfect fit for securing the antenna pole in place. This sturdy threaded rod, along with the nuts, will securely hold the signal receiving component in place and fasten it firmly to the wooden antenna base. The threaded rod is now firmly secured, so I'll move on to the next step, connecting the wires. It seems I forgot to mention this earlier. Using a CD as a substitute for a traditional antenna dish might sound a bit unconventional, but that's exactly where fun and the ingenuity comes in. The reflective surface of a CD works surprisingly well at directing signals toward the receiver, proving that you don't always need expensive parts to achieve solid results. It's a great reminder that DIY isn't about fancy materials, but about understanding how things work. Sometimes, the most ordinary objects tucked away in a drawer can step up and do an extraordinary job. All it takes is a little curiosity and the courage to try. to boost the signal reception even further. I'll make use of the rounded bottom of this Pepsi can and turn it into a secondary antenna dish. Do you believe a spark plug can become a signal converter? It may sound surprising at first, but when you look closer, it actually makes perfect sense. A spark plug is built to handle electrical signals, isolate them properly, and maintain stable contact. Exactly what a DIY antenna converter needs. Its solid metal core and ceramic insulation make it durable, reliable, and easy to integrate into a homemade setup. Sometimes the smartest DIY solutions come from rethinking familiar parts and letting them take on a brand new role. After completing all the steps above, I move on to the next stage, connecting the device's wiring to the coaxial cable. Do many of you here know about coaxial cables? This type of cable is commonly used to transmit signals with high stability and minimal interference. Thanks to its layered structure, the signal core is well protected, helping maintain quality over long distances. That's why coaxial cable is such a reliable choice when connecting antennas, especially in DIY projects where signal clarity really matters. Using electrical insulation tape at the connection points is absolutely necessary. It helps secure the wires, prevents short circuits, and protects the joint from moisture or accidental contact. A small step like this goes a long way in keeping the whole setup safe and stable. This remaining end of the cable will be connected directly to the TV. So the wiring method is a bit different. If you're not paying close attention here, it's very easy to get confused. I already have a straight F connector and a 90-degree F connector ready. With these on hand, connecting the cable to the TV becomes much more convenient and hassle-free. Alright, everything is finally finished. It's a bit exciting. I can't help but wonder how effective this will be when we test it. Let's go ahead and give it a try. The TV is currently showing no signal. I'm going to connect it right now and see what happens. Just a few seconds after connecting it, the picture popped up on the screen. Still, to know whether the signal is truly stable or not, we'll need to watch it for a little longer. So far, nothing seems to be wrong at all. But who knows? The result might be different if I unplug it and plug it back in. I'll test that right now to be sure. And with that, we've come to the end of today's build. Looking back, it's kind of funny how this whole project started with a simple challenge in a mysterious box and ended with a fully working DIY antenna made from things many of us would normally ignore or throw away. A couple of old CDs, a piece of wood, some bolts, a spark plug, and a bit of patience. Nothing fancy, nothing expensive, but everything had a purpose. What I really like about projects like this is not just the final result on the screen, but the process itself. Step by step, testing, adjusting, sometimes getting it wrong, then figuring out why. That's the real heart of DIY. It reminds us that you don't need the latest gear or professional tools to create something useful. You just need curiosity, a basic understanding of how things work, and the willingness to try. The signal turned out stable. The picture came through clearly, and even after unplugging and reconnecting, everything kept working as expected. That's a great sign, and honestly, better than I first imagined. More importantly, this build proves that everyday objects can still surprise us when we look at them differently. If this video gave you a new idea, sparked your curiosity, or simply entertained you for a few minutes, then it has done its job. Feel free to experiment, improve on this design, or come up with your own version. That's how knowledge grows. Thanks for watching all the way to the end. Take care, and I'll see you in the next project, where we'll keep turning ordinary things into something unexpectedly useful.